All right. It's my pleasure to introduce Anand. Anand joined Northeastern last year. He's a member in business school in my group there, the supply chain and information management group. And he does really interesting, there's lots of different work, but a lot of it also is very networky. And so we're excited to have him here and tell us both an overview of what he's generally working on and then a deep dive in one specific paper. So
thank you, Chris. Thank you so much. Right. Good afternoon, everyone. Thank you for coming. So I've been in Northeastern for almost 1.5 years now, and I was looking forward to being here and interacting with some of the colleagues here and researchers here. And in the end, this was a great opportunity before the semester folds up. So my agenda would be, as Chris was mentioning, to start with what I've been working on over the course of several years in different domains, mainly in business and organizations, and then get into one of the papers. So name is Anand. My main research question that I look at in almost every study is this broad framework, which is how do firms, teams, and individuals learn, adapt, and organize. Right? So this is very important as part of the overall theme that I look at. And mainly because I'm in operations and supply chain management, I start looking at things like processes. How do they organize and adapt processes that might be necessary? How do they adapt supplies? Because supply chain is one of the areas that I focus on. So what happens when you are dealing with suppliers, distributors? How do you manage that? Technology and innovation. So that's at a very high level, that research question. And it basically boils down to 3 broad buckets, one being process management, where things like strategic, structural, and operational issues of process innovation, whether it's TQM, quality management, whether it's implementing Six Sigma, how do you ensure that people are all on board, process re-engineering, etc. So that's the process management side of things. Technology and innovation management is all about investments and planning for technology. So if you're collaborating with some other firms or other individuals for innovation, how do you organize, how do you adapt in that process in a network setting? So all the papers that I'll be talking about today will be mainly on networks and how they all connect with that basic theme that we all are interested in. And finally, relationship management. How do you manage governance? How do you manage collaboration, coordination? Because when we're dealing with companies as suppliers, then we are dealing at the organizational level, some sort of collaboration. When we're dealing in teams, we're dealing with team members and trying to collaborate. So that's sort of the framework within which I try to look at most of my research questions. Most of them are guided by empirical data. So I do collect data, whether it is ethnography or case studies or even secondary data, and then use that data to sort of inform in different forms, whether it's using networks, using econometric, combining the two, using agent-based models, things of that nature. So I've worked in various sectors. Prominent ones, I would say, are health. There are quite a few projects that I've done in healthcare. There are quite a few projects done in automotive industry. And then NGOs also, I've worked with a few of the companies. Are quite different, right? So the objectives are not necessarily profit maximization. With targets, so their retail industry became one prominent area. So I spent 6 months trying to manage this idea of how do two teams, one is the AI team, mainly computer scientists and mathematicians, trying to tell the algorithm that with some resonance with what that systems perspective is all about, the complex adaptive systems perspective is. So within methodologies, I mentioned a lot of them, but I'll talk about mainly the two which is really relevant, agent-based models and network models and analysis, whether it's using simulations or using econometric data followed with simulations. So that's sort of the background at a very high level from theoretical and methodological perspective. I'm going to go into certain studies that I've conducted. I'm not going into details of these studies, but they will show you the flavor of things that I've done on teams and organizations, starting with the one on surgical teams. So this is how surgeries are conducted in US. So we actually sat through 102 procedures. So my doctoral student sat through these procedures. We recorded what was going on during the entire time, different types of surgeries. Some of them would be 30 minutes, some of them could be 6 hours long. So you're trying to understand the basic question of why do people waste the supplies that are required for surgery. So you need a lot of supplies and instruments, and these instruments are being wasted quite a bit in the US. Quite large amounts of money is being wasted in that area. So that was our bigger question, which is what to do about this OR supplies. How do you ensure that they are managed well? And to do that, we had to collect different types of data. One is the secondary data of what these instruments are, how much do they cost, what exactly happens after it has been used in a surgery, are they thrown or not? The second kind of issue that we had to ask was whether they are planning for these supplies that are going to be brought into the operating room, because there's always a tray in which all these supplies are coming in. So what's the background planning that happened in determining how many supplies are needed? And each surgeon could have their own tray. So surgeon can decide what needs to be there. So two cardiology surgeons could have very different sets in their trays when the surgery is being conducted, even though they are doing the same surgery. Right? So that's something which we wanted to see how they were planning for it 3 years before the surgery actually happened. So we conducted how many times they iterated it, how many times it changed. But the most important thing from network's perspective was we were trying to examine how people were communicating with each other during the time when surgery was conducted. So we created a matrix to really capture the modes of communication, tones, as well as the directionality of communication among all these participants. Now, a unique thing about surgery teams is that it's really a community of practice, right? It's basically a shared values are getting created, collective intelligence. Chris, you work on this area. So it's, in some way, you are working together over time in this team. And oftentimes these teams are repeated. Some surgeons have some leeway in deciding who the circulating nurse will be, who will be my scrub tech, etc. So they end up iterating with the same people again and again. So we wanted to kind of capture this idea of the community of practice through the communication protocol that they are adopting. And that's where we use the concepts from network, capturing the communication, the types of communication that was going on. And then our basic question was, if they were planning in a certain way 2 years before the surgery happened, does that impact the unplanned cost? Unplanned cost in the sense of extra supplies that are being brought in, or a nurse having to go out to get the supplies because they're not there. Sometimes what you need is not there in the tray, so you have to go out and get it. So is that connected? And the next one was what happens about the communication intensity, especially the network density of communication among all these people. So we examined this in one of the studies, and right now we are taking that data and working on this concept of creating new teams where different experience levels of surgeon, circulating nurse are mixed and matched. So what happens when you mix and match people with different experience levels, create different networks of members conducting that surgery, because we don't have the luxury to really ask them to create these teams, which we want. So we could do that in simulated setups. So we are creating those networks and examining how those networks can influence some of these outcomes. What are the ramifications for that? So that's some of the direction that we're taking with the surgery context from network's perspective. Yeah.
400 hours or 400 hours, this is your
we were inside in the operating room. Yeah. So my doctoral student was sitting, and I was so he was sitting and collecting data during the surgery.
This is the manual annotation.
Manually, yeah, sitting at the time when the surgery was about to start, all the way collecting data, and after the surgery, going down and all that was thrown out, taking in a bag and going down and washing it off, and then going into the system to see what the cost was, so that we know what exactly was being thrown. And so that kind of work. Yeah. Any other questions about this?
This is a publicly available data set?
No, it's with a certain, yeah, it's a hospital system. So I was consulting with that hospital system, and as part of that, it emerged as a project, a research project, and that's how the student got involved.
Can you say which hospital system?
No, I can't say that. It's in Michigan. Yeah.
Yeah.
Any other questions? The second sort of study that I want to emphasize is on supply networks. And this one is using Honda's data. For Honda Accord, we collected data of all the supplies that go into Honda Accord and the suppliers that supply this. It could be raw materials at different levels. You have the supply network. And we wanted to kind of understand two types of networks here. One is the material flow network, which is which supplier is supplying to Honda or to its supplier who then supplies to Honda. So there is a chain there. And then the other one is the contractual network. Who has the contract with that company? It doesn't necessarily is the case that the company who is shipping you actually has a contract with you. It could be that your buyer actually has a contract and is asking that supplier to send it to you. Right? So there could be many of those connections that could be there in contractual network, which would be different from what happens in material flow network. So our question here was about how much control should Honda and its first-tier supplier, because typically it's a very complex network, so the focal company does not have the ability to manage the entire network. It's quite deep. So they use the help of their first-tier suppliers to find a way to reach as far away as possible to the second, third, and fourth tier, etc. So the question is, how far should they go to create direct contractual networks with suppliers, Honda or the first-tier supplier? Right? So more control has its advantage and disadvantage. It can slow down the process. So we were trying to examine the level of control that they should exert. And this was done with NK models. So we were doing an NK kind of analysis here. And what happens when the complexity, the NNK were capturing the complexity, what happens when the complexity of that setup increases, the rugged landscape and all that analysis. So we were trying to analyze that, and that's one type of a network study, which is on the supply network side of things. So this is not at the team level, individual level, this is more firm level. So it's organizational adaptation using controls based on complexity of the network. Questions on this?
What is the central node of a data? There is no name.
So that's the
other one that is contracting.
So this is one of the companies here. This is one of the first tier suppliers. So it could be one as a GTI here. The GTI, yeah. Another automotive industry buyer supply network and product quality. So here we are looking at this. So in an automotive industry supply network, different systems can have its own network. So electrical system will have its own network, braking system, exhaust, navigation. Each of them have their own supply network. So we wanted to sort of understand the role of the network structure, which is the buyer network centrality in that network, how much central the buyer is, and the strength of design interface. How much is the design of that particular system tightly connected with each other? So for instance, an exhaust system is a lot more modular in nature. That is, you can easily outsource it and your supplier can make it and then you can plug and play. Whereas an engine system is not. Engine system is tightly integrated with the overall car. So you need a lot more of that communication that has to happen with your supplier to ensure that everything is going on well. So the level of centrality of the buyer now starts to play a role depending on the design interface of the system. Right? So we wanted to examine that connection between the two, the network and the design interface, and see how that might impact product quality, where product quality for us was the number of recalls that happened for that product. How many times products were recalled for that specific, and what was the recall reason? Because recall could be because of engine system, it could be because of electrical system. So we specifically captured the cause for the recall at the system level and then examined that. So there we looked at 13 automotive firms, their suppliers, and the buyer-supplier relationship that was created with that. And the example was, as an example, this is just an electrical system with 13 suppliers and 13 buyers and all the suppliers. So we examined this as one example but then there will be another one which is for the braking system and then other systems. So this was another study that we conducted in automotive industry. So the previous two slides, this slide and the previous one, relates to that automotive context. Questions on this one? Right, so that's one. Then this was study which is mainly simulation study using agent-based model. The topology of supply. This was done long back when there was this whole analysis of topology and robustness coming from many of the studies that people from Network Science Institute have done in physics and other areas. So that had motivated many studies around this. So this was published in 2010, long time back. But we were examining things like the structure, the topology of that network, and letting this network play be a game in some way. So there's a buyer, there's a distributor, there's a supplier, there's a manufacturer, and we created different type of topologies based on scale-free or random network systems, and then tried to examine how robust they are. So that's looking at things which are important from the network point of view, like average path length, clustering coefficient, all those things. But the outcome variable was mostly in terms of the inventory levels, stock outs, things of that nature. So this is a study which we did mainly through simulation with somebody in computer science at University of South Carolina who has interest also in networks and complex systems. This one is a behavioral study. So it's a behavioral experiment that we conducted with a company, a pharmaceutical company in Europe, where practicing managers were asked to sort of act out a role of the focal firm or a supplier who is having patent for the product, so very strong raw material supplier, etc. So we put them into a network. In some way, it's a network of networks. So each network, so for instance, this would be one set of network, but there's an interface with that other network through one of the entity who's kind of boundary spanner. In one case, it's a buyer, the other case is a supplier. So two different networks. This person is a boundary spanner. And we let these players play a game around with this network in terms of, so it's a game theoretic model where we are trying to understand, what happens when the incentive structure within that prisoner's dilemma type of structure, if that changes in this network of networks, how would they behave when the objective is collaborative innovation? They all are expected to innovate in a common pool. And that investment, how does that get influenced? What's the role of sanctions when we include sanctions as part of their role description, that if they don't do certain things, they will be sanctioned, how much that will improve the level of innovation, collaboration that they will conduct. So that's sort of a study we did with, again, practicing managers with a big pharmaceutical company in Europe.
Excuse me, I'm actually interested in that paper. How can I find this?
I'll send it to you. Yeah. And this one is right now a work in process. Still, data collection is going on. Here we are trying to understand the knowledge flows within supply network. So we are trying to look at the supply network, again, in automotive industry. So there will be supply networks across different systems. So GM's exhaust system will have a supply network. Renault's exhaust system will have a supply network. Toyota's exhaust system will have a supply network. So that's the layer above at the top. But then there's a layer of patent citations that happens among suppliers and buyers in that network. How much they are sharing knowledge about a new innovation within the network. And that's the layer below. So we're trying to see what happens when there is a tighter connection in a supply network with respect to the patent citation network that they have within it. And would that have any influence on outcomes like product or organizational variables? So we are still at the level of data collection, but we will be taking this towards the network and other domains. So that's an example of a study that is in process right now. So that's another example.
So can you say again, what the bottom layer is?
The patent citation. Mm-hmm. And the top layer? The suppliers, the supply material flow.
Material flow.
Yeah, within that particular system.
So each edge on the lower layer would be a citation.
They're citing with each other, yeah. So yeah, on each other. Forward citations or backward citations, yeah.
So exhaust is just the exhaust of the car.
Of that specific brand, yeah. Mm-hmm. It's about 25, 30 years worth of data. So it's a it's a panel data. Right. So this one, I don't know where it's going to go, but to a certain extent, I was thinking of this more from one of the projects that I did in Santa Fe Institute, where we were looking at these networks in ecosystem. Right. So you have these predator prey type of networks and other networks. So we were working on one of these islands right across Spain, where there is quite a bit of that happening. So we wanted to see whether there is something of that kind which we could bring from the theoretical point of view, from the network's point of view in this, but still at a very conceptual level. We don't know where we are going with that. But we do think that there might be some interesting thing coming up. All right, so that's sort of the overview of few studies that I've conducted on using networks as an important variable, and oftentimes the most important variable in those studies. Now I'm going to go into one study which I'm going to go a little bit in depth, and this one again goes to an individual level sort of interaction and networks. So this is collaborative dynamics in open source software development. And in open source development, there are certain unique aspects in it, which makes it an interesting context to study from organizational perspective. So we want to understand the influence of team interaction and the role of the project manager, the one who owns that project in the open source project. So it's been co-authored with Sukrit Pal, who was my doctoral student now at Iowa State, and Zia Zhuo, who's in Chinese University of Hong Kong. So we collaborated on this. So this one fits into this intersection between technology and innovation management, because the outcome variable in our case is sort of the number of issues that were closed in a project in this product development context. So they're trying to develop a new software, and in that there are issues to be closed. And there's a relationship that is going on, the governance aspect, the managing of governance across people through interactions. So this will be the outline. I'll start with the context, research motivation, and then the objective of this research, followed by hypothesis that we have, the design that we have chosen, what are the results, and some of the robustness checks we have conducted, followed by implications of our study. Right, so this context, as I mentioned earlier, it's unique and interesting in the sense that this is a self-generative collaborative template where most of the time these amateur software developers are voluntarily coming and contributing. So there's no hierarchy, there is no structure which is making them come together and expecting them to do certain amount of work, certain hours. So they just do it voluntarily. That makes the project management a little bit complicated. You really want the outcome still, but it is within the context where you don't have necessarily the hierarchy and the structure that a normal project might have. Right? So there is voluntariness, there is the traditional chains of commands that are not there. The configuration itself is dynamic because people might join and leave whenever they want. There's no restriction when they can leave that project. And there's no face-to-face communication between people. So there is that challenge for specifically project managers. And in general, for projects to be successful, we need to know that. Now, the context here is that the volunteers contribute in this OSS project, update code blocks in a software module. Now, these updates are typically pushed to a module manager who is the project manager in our sense. And that person then approves it. Once that is approved, then that particular module is added. That code change is added to the module. And during this time period, the first two steps are going on. There's communication happening between coders, between the software developers. So they're communicating with each other about what they're doing and why they're doing it. And so there's that communication that's happening. And that is happening among people who were there, sometimes leave, and the new person comes in. So there's that dynamic nature to it. And there's no formal communication that is actually capturing everything. It's happening on that system where the discussion board posts are there. So it starts to have an asynchronous nature, complex nature, and that needs to be somehow sort of made sense of. At least if you want to really manage projects, you don't want to make it too complex, because if there's too much of interaction going on, it could create complexity and it's very difficult to then manage. And you also don't want to have that communication too less so that there is not too much of information sharing happening. Right? So you want to have that right balance. So we want to really capture that with the OSS platform. And that's the discussion board post is what we are looking at. It's a thread-like discussion. So I know I'm responding to X, then the other person responds to me, and that other person can also respond to X. So I can actually capture that in these thread-like communication. So a pattern gets emerged when we start looking at it, especially when we start looking at it over time. So if we are observing 2 years worth of data, and if that 2 years worth of data is divided into weeks, we have 102 weeks. So every week, what would happen is a specific sort of communication pattern starts to develop during that week. So we can sort of discretize it into weeks and therefore capture that essence of communication pattern in the form of networks. So we focus on that communication pattern, create networks for each week for all the projects that they have. Right? So if there are n projects and we're looking at 104 weeks, so we created n times 104 networks. For each network, we then captured a few things that we then analyze to understand how that could impact the outcome. So we focused on GitHub as our data source. The projects had to have certain characteristics. I'll talk about that, which kind of projects we wanted to make sure we are using. These developers do not have any authority to make changes to the original code directly. They typically have to fork, make changes, and then through the pull request, they commit and then submit something using a pull request. So that's sort of, all of you are familiar with that concept. So it's something which happens in GitHub all the time. So it provides us a unique way to sort of understand what exactly is going on while this 3 steps are going on in terms of the communication during that time. Right. So the owner engages in tasks that are related to interactions. They can decide who should communicate to who. At times, they can create those patterns. They can make sure that these discussion-based pull requests are managed and oversight is given to that in terms of which one is getting added and what the characteristic of this is. Contributors define the project boundaries. So every project has certain contributors, and then another project will have a set of contributors. Some of them can be overlapping, but in some way there is a boundary for that project based on the people involved. And they can stop contributing at any time. So that makes it a dynamic changing network every week. So we do see that change every week. So this is how it works. We would have started with these 3 people. A person comes in, joins, another person comes in and joins, and then somebody leaves, a new person comes in. So that keeps on creating the network. So that's where the network aspect comes in play. The privilege that the project manager has is in determining who should be able to add or change codes, right? So that privilege, they do have some say. They can change the visibility of the repository. So that's one of the project management tasks that they can enforce. For certain people, they can change the visibility of the repository. They can limit interactions with the repository for certain people, depending on what's going on, how much complexity is adding, what's going on with the interactions. They can manage access of the collaborators in certain instances and maintain consistent coding standards across all the collaborators. So they have certain abilities to manage these projects once they start seeing it's going out of hand. Right, so that project manager typically is also a focal point in this study. We wanted to see the active participation of that project manager in this project, how much that contributes in the outcome that we have. Right, so that's the background context. The motivation is social network theory, and we are trying to capture the role of network, of that interaction network, communication pattern that is generated. What we are trying to capture there is social capital through the density of communication that is going on. And we want to see whether that helps in some form directly the level of issues that are getting closed in the project during that week. Right? So the density of network communication, does it help in increasing the number of issues that you're closing? Because open issues are basically all those bugs that have to be fixed for the software development. So does that happen? But there's countervailing forces there, right? So there is complexity that gets added if interaction keeps on increasing and density increases. On the other hand, if it's too less, then you don't have the right amount of information sharing. So we're sort of building on that idea. Now, it is different from traditional projects because there are a few studies that have captured the idea of network density in traditional projects where there's a face-to-face communication and there's formal structure. The reason why it is different is because typically the traditional project studies that have been conducted in academic literature have this underlying assumption that there can be free-riding behavior. So people can be having free-riding behavior if they're not properly governed and controlled. And that's true because that's why you create a formal structure, you have that hierarchy and all those things. But there's no such free-riding behavior in OSS because these people could easily leave whenever they want. It's not like they've been asked to be there. It's a voluntary contribution. There's no defined team structure. That's another difference in the assumptions between the two types of projects. And then asynchronous communication, which may not be completely distinct nowadays with traditional projects, because some traditional projects still have now started having asynchronous communication. So that's probably partially true. But the first one is definitely quite different with respect to open source software projects compared to traditional ones. And because of those assumptions being different, the effect of the evolution of the social capital over time in 104 weeks, how that would impact the outcome is unclear. We don't have at least any study which had contributed in that direction, as in what happens when these networks evolve in a certain way with respect to the number of the outcome that we are looking at. So we're trying to understand how within team member interactions through these communication impact the outcome, which in our case is issue resolution, and how the project managers' active participation in that network, how much they play a role in talking to each of these members, how much that contributes, first of all, directly to the issue closure rate, and secondly, as a moderator to the network density. So if the density goes up or down, does that influence better? If they actively participate more, does it influence a little bit more, depending on the type of communication that's going on? Questions until here? With the context, motivation, and yeah. Say that again? How many GitHub projects? Yeah, I'll come to that. So I'll come to the data, yeah. All right, shall I move? So our first hypothesis is within team interactions, the network and the network's density level, how that influences issue resolution, the number of issue resolution. And this is where I was mentioning earlier, we're drawing on social network theory and building on that. And the concept of network density is our variable here of interest and its impact on every week, how many issues were closed. Now, there are two countervailing forces, as I said. One is that the team interaction exposes members to diverse viewpoints. As they're interacting more, the density is increasing. They get to know what others' perspective is, why they're making changes to the code, and what does my contribution do on top of it. Right, so that would suggest that it should increase the number of issues that are getting closed, because you're getting to a common ground in terms of your understanding of that project. And that mutual interaction also help team members to exploit complementarities. That person is really helping me with that particular problem, which I was not able to fix. And therefore, we're complementing each other in that code fixing process. So all that would suggest that issue closure rate should keep increasing as team interaction keeps on increasing, as the density of communication keeps on increasing.
Density is the real number of edges.
Yes, total number. Yeah. Number of instances of communication to the total possible communications. Yeah. And the alternative way of thinking of this is that when there's an asynchronous communication and there are discussions happening simultaneously, all these interactions are capturing something about the code, but this could also be possibly about different topics at the same time, right? Different people are talking about different things. So we are capturing this as edges, and that could increase the number of messages exchanged, making it more difficult for information processing on the part of the teams and the project manager and others. So that would increase the coordination overload among people, right? So that could be another force that could be happening, which is the coordination overload also increases, which could decrease team productivity, that can decrease performance. So we have the alternative thought that it can also go down as against just going up. So together, when we combine the two, basically, we expect that it should have an inflection point. Until that point, you should be expecting improvement. After that, it should go down. So we wanted to capture that inflection point for individual projects. Is that existing? And if so, what exactly is that, depending on the type of project? If there are 6 members, number of instances of communication, whatever it is, at what point in time that starts to hurt? Because that could give the platform as well as the project manager certain guidelines of what to do. At what point in time to intervene so that something can be changed. The second, so that's the first hypothesis, inverted U-shaped relationship between our independent variable and dependent variable. That's what we expect. The second hypothesis relates to project managers' active participation in that network. So how much do they themselves put themselves into the communication channels? How much do they say during these interactions? So we looked at them as one of the nodes, but their specific communication there. And here we wanted to first capture what's the direct effect of that, the direct effect of project managers' active participation on the outcome. And then later on, H3, the third hypothesis is what that does to the effect between the interaction of team members and the outcome. Right. So here, the project manager, when they are directly involved, they can develop and exploit some of this organized knowledge structure that is getting developed. Right? So if they can see all these people are communicating, and I'm also talking quite a bit, in some sense, my project management role here is to ensure that there is something developing here and I'm reinforcing it. It's positive movement towards the code and it's improving whatever the outcome we are expecting. So I want to reinforce that. Or I could be also helping in sometimes, elevating some of the confusion that people might have. So if I'm communicating, I'm doing other tasks also with respect to ensuring everybody is on the right page. So project manager, in some way, when they're communicating directly, are helping with the goals of the project, and we would expect that that should directly contribute to project outcome. That's our second hypothesis. We want to test that. But then the main hypothesis we really want to test is the moderating effect. And moderating effect is basically the role of the project manager's active participation on that direct effect that we saw. Right? So how much could that be shifting the inverted U-shaped curve? When I say it shifts the inverted U-shaped curve, what it means is that the inflection point is becoming farther out. Right? Instead of the performance starting to decrease after a certain number of communication density, it gets further out, which means that they can have little more density and still continue having the positive outcome. So we want to see whether that inflection point gets moved to the right. And second, we want to see whether it flattens the curve. Right? So there are two types of effect that can happen in the moderating sense. One is the movement to the right, and the other is flattening of the curve. So I'll talk about that. The moderating effect can be one that the project manager could be sharing information with the team and acting as a conduit through whom all this communication is going on. So they become sort of a channel for everything that is moving out. Right. So the extent of project managers' active participation then is expected to positively moderate this relationship and improve that issue closure rate. They can enforce classification of the messages, which one goes where, what kind of message it is, what are they trying to do in this particular activity, the type of message, who this message is intended for, and the role of the sender. They could classify them. And that could be one activity that they could be doing through this active participation. They can take the final decision when conflict is arising between team members. That could be another thing which project managers could do as part of the active participation. They can set operating standards through these communications. Now, we don't have access to exactly what each of these communications is all about, right? We don't have the qualitative nature of it. We just know that there is a communication going on. So, but these are things that they could be doing in that communication. So this is where we are conjecturing to a certain extent that they could be doing these kind of things. And that is actually not directly impacting the outcome. It's impacting the interactions effect on the outcome. So that's where we expect the first hypothesis, H3, the two of the, in hypothesis 3, we have two of them. First one of the two is that the active participation alleviates the negative effect that team interaction can have on issue, that it flattens the curve in such a way that it does not come down as dramatically as far as the outcome is concerned as the network density keeps on increasing. Right? So we should expect that it should not just bring down the outcome after a certain density. It is because they are doing all those things that we just talked about, the flattening of the curve. So that's H3A that we want to test. And H3B is essentially what I was mentioning earlier, which is, does it sort of move it to the right, which means that the difference between X2 and X1 is positive. And so there is an inflection point that happens later in the curve rather than earlier. Both of those things are going to be positive for a project because in the first instance, you're getting the benefits and then the coming down of that project issue closure rate is slowing down. So you get more benefit for a longer period of time. And here, again, the inflection happens later. So that's a good thing. Now, coming to some of the one question that was asked about the data and all that. So here we had to collect data. So we collected data from GH Torrent and looked at real users. So there are fake users and real users in GitHub. So we want to make sure that we distinguish the two. We want to make sure that these projects are the ones where the user has owned the project, has been sending pull requests, has been commenting on issues. All these things are happening in that. Otherwise, it could be just a course project, right? A course project or a course syllabus. There could be some of those GitHub projects, but those are the ones we had to remove. Anything which was owned by corporations, we had to remove that, because those corporation projects have a structure. There could be people from that company. Google could have its own project, and where many of the project members are part of the company. So they have a formal structure. We would not be able to capture it. So we wanted to remove that. We wanted to make sure that these are individuals starting a project and trying to manage that in the setup that we are looking at. So these are all non-corporate type of projects. So they must satisfy 4 criteria. They contain more than 2 core members so that a network can be formed. For the entire time period of the data set. As I said, we are looking at 2 years worth of data, weekly divided, so 104. For every week, we need to have at least 2 members being there so that there's a network that is there. It contains at least 1 fork and 1 watch to filter out repos that are created only for the purpose of storage. Like I mentioned, a syllabus or a course document, not that kind we wanted here. Consider original projects which are not forked from an existing project. So these are not a forked project, but the ones which were the original ones. And then have comments posted by their members under either pull requests or issues. So there are certain criteria that we had to go and look at every project to ensure that they satisfy. Now, to account for events occurring in a project from the time it started, because if suppose we pick the project from the middle of it, and then look for 104 weeks, then a lot of things would have happened before that, and that would be completely gone. So we wanted to make sure that we look from the time of initiation until 2 years for every project. So it has to be 2 years from the time of initiation, so that we are really capturing the dynamics from the beginning till a particular point in time. And we could capture some of the other things which needs to be controlled for as control variables. So we do have some control variables in terms of the size of the project and all those things. Now, a project is considered active during the time period if there is interaction between at least 1 pair of team members that is going on, and at least 1 issue is resolved during. So then it's an active project. That's something which is an important element here, because otherwise a dormant project for multiple weeks, sometimes for a whole year, would not really make sense here. So after removing all the projects which were not satisfying all the previous considerations, we also looked at external communication platform that projects could have used, right? So people could be using Slack among team members. There are many other ways in which people can be communicating in these projects, but our objective is to see how much team interactions actually impact outcome. So we had to be very careful about how many of these projects actually had outside communication that was going on, right? So we had to go in every project's description to see if they were using external communication platform. Some of the times we had to actually also go by Wayback Machine and gather data for those which were not existing in the system, because there's this historical data that's available. So we could go and check whether they were actually using any of those other, or is it the main platform being GitHub's own discussion board. So that's where, after removing all of this, we had 1,599 projects, coming to your question, comprising of 120,243 weekly observations.
I get that general idea of putting on some filters to pick meaningful projects. Why so few? There should be like millions of active projects on GitHub. How do the filters get it down to 1,600 projects? There must be more active projects on GitHub.
So,
especially if you, like, how far?
2 years. For 2 years, when we look at 2 years worth of data, and we want to make sure that every week there is an active participation happening, and we ensure that during those 2 weeks, from the time of initiation till the time it is 2 years, we ended up getting these many projects. There were not any more of projects which actually, or we could have situations where we did not have the required data that we needed. Like, for example, we don't know what exactly happened about the external communication that they might be using, and all those things. Not very clear. So that could be, and all the other bullet points that we mentioned could be all the reasons why it ended up becoming a set like 1,599 projects. Every week. Every week.
This is quite a frustration. So
maybe.
Down.
How you say like from initiation
2 years,
but over what time window?
So we just collected for 2 years. So we just wanted to collect the 2 years worth of data and issue closure. So we didn't want to take all the data that exists for the entire life cycle of the project. Any project that started, let's say in 2019.
Well, that's my question. Which year did you start the data collection?
So I think it should be in one of the slides. I don't remember now, but there is a certain time period, I think 2013 to 2017 or 2018. So during that entire time period, whenever it's, so it's a long enough, I mean, there is a 6-7 years worth of time period within which we wanted 2 years worth of data set from each project.
No, you don't understand. So is this scattered in time or it's a precise time?
So some project could have started on day 1. Some project may have started on day 5. In a period which can be in a 2 years. No, it could be 2
7 years.
In a total 7-8 years window. We were looking at any project that has initiated during that time and has 2 years worth of data.
Oh, okay. Yeah. So this is it's I would say it's.
So it could be moving window. So it could some of them may have started in 2014. Some have
from the start to
2 years.
For 2 years.
Yeah.
So that is not necessarily the end of the project.
That's not the end of the project. There could be some projects that are longer than that. Yeah. Right. So every node is a project member or a project manager. Each edge captures the frequency of participation, so it's a weighted network. So it's undirected and weighted, and basically capturing any time when there's a commenting on an issue or pull request that's going on between people, right? So that's what we're trying to look at. Network X module is used to develop relevant matrices that we needed. So this is sort of types of networks that can exist in a given setup where the project manager sometimes is in the center. Basically, only 2 members are communicating with each other. Everything else goes through the project manager. In some cases, all the project members talk to each other. They have enough latency to talk to each other, and sometimes it's like that. So there could be different network variables that can come out of these types of networks that exist over the weeks that we have, 104 weeks, right? So each week could have a different structure. So network interaction is the density of co-participation on a certain comment on a specific issue that 2 people are commenting on. So that's our team interaction. So each edge connecting the node in the network is weighted by the number of issues and pull requests where 2 members have co-participated. It's the same issue on which 2 people are co-participating, and that issue is what we are looking at, whether it was closed or not, because the outcome variable is will they close that issue after all this is going on. Project manager's active participation is the degree centrality of that project manager in that interaction network. So how central they were in that network, and that's what we will later on check with respect to the outcome. And the outcome is the issue closure rate, number of issues closed per week in a project. So that's sort of a process outcome. In some way, the product development innovation outcome, because that's leading towards a final software that they want to build. Because these projects can differ across many factors, so we had to control for them using team size, number of commits, because it captures the level of technical activities that is going on. Number of forks captures the popularity of that project, because that could bring more people in. Number of watches, actually both of them will capture project popularity. Open issues in the previous week, because that will sort of partially determine how many issues have to be closed in the next week. How many issues were there in the past? So that's a sort of dynamic structure of this model, econometric model that you will see. And then time fixed effects as part of the modeling itself, which we had to do. For the member level controls, we also had to capture the tenure of the project manager as well as project member. How long have they been on the platform? So we had to go back and see when they joined GitHub as a member, and that gives sort of experience in some way, how much experience they have with this platform. Is project manager involved in other projects? Right? So that's something which is important because it captures the workload of the project manager. Maybe they cannot actively participate because of that reason. And then likewise, team members' involvement in other projects, which also captures the workload of the team member. So we had to control for both project level characteristics as well as member level characteristics as part of this. Now, we use the partial autocorrelation function approach first to see whether there's autocorrelation between the dependent variables across these 104 weeks. Right? So our dependent variable is issue closure rate. There is clearly an expectation intuitively that they will be autocorrelated with each other. So we had to first test whether that is true. And we find that it is indeed true that there is partial autocorrelation happening between these. AR1 serial correlation does exist. And hence, we had to control for that. We had to address that as part of the model specification that we have here. Right, so that's what we do here. We estimate this dynamic control variables. We took those and then created our instruments by taking the estimated value and then average subtracted from it. And then that's where we do the two-step control function. So not going into the details of the technical aspect of the econometric estimation model here. So this all is the details behind that. So you can always read this in a paper, which I can share. The summary statistics for the data sets, including the control variables and the results. So we find support for the inverted U-shaped relationship that we were talking about, the H1, that there is an increase and then a decrease in the issue closure rate as the interaction keeps on as the density of interaction keeps on increasing. We don't see any direct effect of the active participation of the project manager on the outcome. So project manager's active participation does not directly impact the outcome. So that's our hypothesis number 2. So we don't see that as a significant effect. So this is for the first hypothesis. We also did the U-test. Now, first, we had to check whether there's an inverted U relationship, and then we did the U-test to see whether it is significant. And we do find that there is a U-shaped relationship between those variables, and that's something which we could say with certainty. But active participation did not significantly impact, so we cannot say that there is a direct effect of project manager being too involved on issue closure rate. They don't directly get those issues closed. But they do help with the moderation effect, one of the two, not both. Right? So we tested this through certain steps. So first we had to look at the interaction of the active participation with the team interaction to understand whether that's significant or not. But by itself, it would not really, it would capture H3A only, not H3B. So H3A is about the flattening of the curve. So it does flatten the inverted U-shaped curve in such a way that the coming down of issue closure rate is not at the same steep level as it used to be earlier. Right? That happens. But the shifting of the curve cannot be tested just by doing this interaction effect. We had to do a few more things after that. So for that, we had to take the first derivative of the estimation model with respect to team interaction, set it to 0. And then that results in an equation like this. And then we had to take the second derivative, this time with respect to active participation. And that is then tested for different values that we have to put there. So we have a test there which can be done on that second derivative to capture whether that's significantly moving the curve. And we do not see a significant level. So we don't see that actually there's a shift in the inflection point to the right. So we cannot find support for our hypothesis H3B. We only found support for H3A. Right? So only flattening happens. So 2 hypotheses supported and 2 hypotheses did not support. H1 and H3A were supported. H2 and H3B were not supported. Okay, so that's sort of our results. Some robustness checks. We use different dependent variable. We use different operationalization of the explanatory variable. We also address the over-dispersion of zeros with other estimation models that we could consider. Different set of instrumental variables were also considered. So all those different tests to ascertain whether those two hypotheses that we found support for indeed are supported. So there are some implications that from theoretical standpoint, I think it resolves some of the aspects about the open source software development project vis-a-vis traditional, as in what the dynamics look like and what exactly the outcome impact could be because of all these interactions and project managers' participation. It presents empirical evidence that there's a threshold of team interaction after which there will be a decrease in the outcome. So we find that, and we could show those values for each project, what exactly that would be. And it contributes to the literature on project management in virtual setting, how project managers should be managing these projects through active participation. What does it do? What can it do? Inflection point was derived for different projects. So as an example, we looked at one of the projects which had 6 developers. And then in that project, we found that the active participation at high level by project manager can improve that overall closure rate by 31%. So there is some quantitative analysis that we did to show how much project managers' active participation can contribute towards making the project successful from the issue closure rates perspective. And for the OSS platform, the implication is to consider developing a system that can trigger some of these things, right, automatically. Depending on the number of developers, depending on the level of interaction that is going on, it can determine when that inflection point could have arrived using some of the results that we have, and then trigger the project manager certain things that they could do at that point in time. At least they can choose to do certain things that they already talked about. So that's one of the sort of implication for the platform itself. So that's our overall sort of study. I think I'm concluding with this as my last slide, but I'm open to taking any questions or comments.
Thank you, Anand. Time for maybe 1 or 2 questions.
Yeah, so maybe just following up on the question about the data. You can maybe think of a sort of failed open source software project as one that doesn't last 2 years. They fizzles out after 3 months. So, from I don't know, causal inference perspective, what if all the results, you could think of the sort of filters in the data as selecting for successful teams.
Yeah.
And
the outcome will be different. You're saying the outcome variable is project being continuing after a certain time, or is it closed after a certain point in time? So it's more of a survival type of model.
Yeah, exactly.
Okay.
Yeah. And then maybe a quick question about also the identifiability of hypothesis. If the curve is also flat, it would just be really difficult to detect that shift.
There are some methods that we can adopt to actually check to test it. That's what we did. So even if it's flattening, we do have other tests that can capture the shift, which is altogether different theoretical aspect. So I don't see that is a problem here. I mean, we can test both of them, and we do find support for one, but not the other. Yeah.
So what is the maximum? So if you do an analysis of how big are those methods, so what is the statistical characterization of those methods? You will have methods with individuals, and then perhaps a network with 100
individuals.
So
yeah.
I don't know if, for me, what is physical engineering is just doing an analysis that plug everything together.
So we have this correlation matrix. I think the problem here is probably that the team size 8.88 is the mean with the standard deviation of 25.24. So that's sort of the range. That's sort of quite a standard deviation we have in there.
I was curious to see if we see things like distributions which are skewed or things like that. So
depending on the size of the.
Yeah, you know, the average number is just telling part of the reality. To see, for instance, is, you know, you have kind of a long tail on those projects, etc. I expect perhaps that those projects have different behavior than
other ones. Yeah, that's a good question.
In a sense, you know, for me, I in a project with 4 people, I see path that you get to a level where you have an overall communication. Where during a project with 20 people, you might get more clearly what you see. So, for instance, I don't know if segmenting or defining your networks,
you could do that.
Test your hypothesis in a more sharp way or
could, yeah. Possible. I mean, we also find one interesting thing that even if the project size is big, the network size is big, if there are, let's say, 25 people, normally there's a concept of core and periphery. There are a lot of peripheral members who really don't do much, you know, so they might be there, they might put in something. It's mostly those same 8 people or 7, 8 people who are really communicating most of the time. So that is also a characteristic that we observe. We didn't dig deeper into that characteristic itself, but it's possible that even with a 100 team member network, really the core is doing most of the work. So we don't know yet. I mean, we could test that and check that. Yeah.
And I like that idea, but it gets tricky when you do everything on one big slices, right? Like the overall team involved in the project might be very large, but in any given week, only a handful of them are active.
Because when you get 70 or 60 individuals, they will be more active during the week.
I was curious why. I was somehow expecting you would use project fixed effects, but you only had time fixed effects.
So the project fixed effect is getting captured with a lot of those project characteristics, right? So whether it's a team size, a lot of things that we captured there are capturing the project fixed effects in many ways.
I mean, they're capturing part of it, but somehow, like, usually when you do observations over time, you really want to capture, like, what's the effect of having one extra message in this week versus the next week where you have 2 fewer messages, right? Like, you really care about that within project variation. And you have a version of that with your control variables, but not exactly.
Right. So, yeah, it's a good thing to think about. I mean, I think there are some challenges with using project fixed effects in the same sense as team fixed effects. If I use project fixed effects and then try to look at the team interaction, so the team interaction is very much a function of that project, right? So there is the likelihood of not being able to capture the real variation that we want across time for individual projects. So econometrically, I think there are some challenges with using the project like individual level characteristics. So we could have also considered the project member level, but we use control variables for the fact that after controlling for it, whatever the variation is, it is capturing the other phenomenon that is going on. So if it's but it's a good point to think about here.
Well, this the last thing I would be curious. I using the models in those networks. This is something that is, now if you think about what happens in regular networks in many areas, you see that there are patterns that are more abundant than what you would expect on a simple random way. And I was thinking that probably here there must be some building blocks of those interactions, and you know, there is a lot of, probably one could try to differentiate the big networks from the small networks of those kind of models. And there is a machinery that can unleash to the problem once you have the network.
I thought there was another hand somewhere in the back, but may not. All right.
Good. Well, thank you all for coming.
Thank you so much. Thank you.
Yeah, so then if you, this is depends on how is the time resolution.
Yeah, because that's again, that's
Yeah, for. Introduction.
Very nice to meet you.
The executive director of the
Yes.
institute.
I was on some of the email exchanges, and so, yeah, glad that we finally.
Yeah, finally was
Hooked
able
up.
to. Yeah, I'm happy
So you
to-
just starting this September? You just
I started
or-
last September.
Oh,
so
okay.
it's
So
been
you've
1
been
year
here.
and
Yeah.
3 months.
Okay.
Yeah. Sometime. Slowly getting to know.
Yeah,
the
yeah.
university.
Yeah.
And Anand is in the same group as me.
Yeah.
Mhm.
same department.
Good.
Yeah, let's go on the 10th floor.
Okay.
So,
Right.
so we can.
We're done, you can go.